Hello viewers, thank you for watching this once more. Our first topic last time was about coordinates and the straight line. We looked at the length of a straight line, we looked at how to find the midpoints, we really enjoyed. So for today we shall look at the gradient of a straight line. Just like I told you, I'll be going systematically until we finish the whole syllabus of pure mathematics. Take this slowly but you'll enjoy. So let's look at the gradient of a straight line. The gradient of a straight line. In finding the gradient of a straight line, let's take this as an example. Supposing a line passes through a point A, which is x1, y1, and B, which is x2, y2. We shall represent this on a Cartesian plane. So we shall draw a plane of this kind and that. So this is our line we shall take. It passes through points A, which is x1, y1, and point B, which is x2, y2. So you will find that the gradient means the slope of this line. And the slope of this line is what we are going to see. How can we calculate the slope or the gradient of the line? So we shall say, in calculating the gradient is given a simple formula as change in y-axis or increase in y-axis over change or increase in the x-axis. For example, as you move from point A up to point B, it means that y-axis is changing. So this is our y-axis and this is our x-axis. The y-axis is increasing or it's changing, and also the x-axis is increasing or changing. So we shall say, since the y-axis changes, it moves from y1 up to y2. So it becomes y2 minus y1 to see the increase or the change in y-axis over x2 minus x1. For this formula, you can as well say y1 minus y2. But the moment you start with y1, even in the denominator, it's x1 which should be the first. But never replace x up and y down. No, y is always up and x down. Thank you very much. Let's look at an example. In our example, find the gradient of the line joining R, that is 4, 8, and S, which is 5 and negative 2. So we shall say, using this same formula, gradient, which is in most cases given the letter M, should be equal to y2 minus y1 over x2 minus x1. So this will be our y1, y2, x1, x2 for this case will be the point S takes x2 and y2, the point R takes x1 and y1. So we shall say in our y2, this will be our x2 and this will be our y2. This will be our x1 and our y1. So y2 is negative 2 minus y1 is 8 over x2 is 5 minus x1, which is 4. So this gives us negative 2 minus 8 gives us negative 10. Divide by 5 minus 4, which is 1. And therefore, our gradient will be equal to negative 10. Complete.